But first, a West Coast construction site that's a roaring success with workers and commuters. The Lions Gate Bridge is one of Vancouver's busiest commuter links. It's also under construction. But thanks to some thoughtful engineering, traffic on the bridge hasn't had to slow down a bit.
The Lions Gate Bridge. It's a Vancouver landmark, a vital link that connects the city to its northern suburbs, an artery that carries 60 to 70,000 vehicles a day. Back in the 1930s, when this suspension bridge was built, it was one of the biggest engineering projects ever undertaken in British Columbia. But 6 decades later, the harsh air and road salt have taken their toll on the bridge. The structure is rusted. The deck is falling apart. The Lions Gate has seen better days.
It had to be replaced for the safety of the public. For example, we know now that at the South Tower, the expansion joints have gotten so rusted, so corroded, that they don't work anymore. So now on the hot days, the span expands to the south and flexes the tower of the bridge.
And so the Lions Gate Bridge is being rebuilt. Almost everything on the bridge needs to be changed. The entire span will be torn out and replaced. When the project is finished, there won't be much of the old structure left behind.
We're replacing everything on the bridge except the existing cables and the existing towers.
Most engineers would just close down a bridge for months to complete a job this size, but not here. This bridge has to be rebuilt without disrupting rush hour traffic.
This is the first time I'm aware of where this has been attempted while trying to keep the bridge open to traffic most of the time.
The answer is to replace the suspended span piece by piece. Most of the work will be done at night, with many of the crew members perched 50 meters above the harbor. They've started at the north end and they're working their way south. Tonight, they'll replace section number 5. They have just 10 hours to remove a 20-meter stretch of the old roadway and wedge a new section in place. By daybreak, it has to be ready to carry the morning rush hour traffic. Every minute counts. The first challenge is to cut Section 5 free from the rest of the bridge.
Right now we are cutting the top cord. This is a pre-cut.
The key is a huge piece of equipment called a jacking traveler. It's a crane, and it can raise or lower bridge sections using 4 jacks capable of carrying 70 tons each.
This is doing all the lowering and lifting.
The jacking traveler will cradle the old piece once it's disconnected, but it will also act as a support, a gantry, that takes the load once the old section is removed. Engineers can adjust each of the traveler's cables, making them shorter or longer.
Marlon and Olim, have you got loads on S60 now?
The key is to line everything up properly.
We adjusted the new span, lowered it, so it came into alignment with the old span and produced 0 load difference across the continuity link that connects the two together.
When they're certain that the entire load of Section 5 is being carried by the traveler, they can unbolt the piece from the rest of the bridge. Above the deck, the pins that hold the section to the permanent suspension cables are removed with the help of a powerful jack.
It takes about 90 to 100 tons of force to remove the pins. Normally you would slide the pin in with your hands, and then once you get them out, you can put them back in with your hands.
The pins have rusted over the years and become swollen. Removing them is one of the most difficult parts of the job. Meanwhile, the welders' torches are cutting through the last of the old steel beams. With the help of a few pry bars, the 20-meter section of bridge swings free.
There's a little bit of a jump on separation, but nothing too adverse.
With the road deck now in pieces, the character of the bridge has changed, and structurally it's not as strong or stiff.
It's a cable structure and it's like a big rubber band.
It's easy to see and feel the swing of the suspension bridge. Now the crew must lower the section to the ground safely. It takes about an hour for the jacking traveler to deliver the old section to a flatbed truck waiting to haul it away. Then the new section is wheeled into place and attached for its hour-long ride up to the bridge. It will be carried by the same cables into the same spot. The bridge is at its weakest with the suspension span in pieces. The hole is large enough to swallow a city bus. As the new section rises into place, it's once again lined up using the adjustable cables of the traveler. The new panel should fit perfectly to its neighbor. In fact, engineers fit all the pieces together on the ground before the project started, to ensure there were no misfits mid-bridge.
You still have to get the geometry the way they had it in the shop. Until we get that geometry, we can't make the bolted connections.
Good here.
Once it's lined up, they can start bolting the two new sections together. In all, 800 bolts will be used tonight. Above the deck, the bridge's cables are secured to the new section. The new span is wider. The sidewalks will be cantilevered onto the outside of the bridge. That means there will be more room for cars. Because building materials have improved since 1930, the sections are also lighter. Extra weight will be added later so that the bridge will weigh roughly what it did before the project began. If the span is too light, the cables will pull the roadway up and away from the water. If it's too heavy, it will droop. The old bridge is connected to the new section with a temporary hinged link. Metal road plates will be laid over the small gap in the bridge. With everything bolted up and pinned into place, the bridge is just about ready for traffic. The engineers have pulled off the near impossible once again in record time. One section down, just 49 more to go.
When we come back, taking a measure of last resort.